Assalamu alaikum. I am Nafisa Mustari, ID 19101086. Today I will be reviewing a book named Speech and Language Processing, and the chapter is Chapter 20, Lexicons for Sentiment, Affect and Connotation. Here is my group mates Sanjeev Kumar Sen and Ananya Bonik. This is my concept map of the chapter. Now, first of all, I will be starting with affective. Here, tools are used for interpreting affective meaning to analyze sentiments. Affective is consist of emotion, mood, interpersonal stance, attitude, personality. The extraction of attitude is figuring out what people like or dislike. Emotion and moods detect when a learner uses a tutorial system, if they feel uncertain, interested or confident, if a blogger blog post is depressed or not. Conversational agent can be made better by detecting a user's personality, such as where they are, where an extrovert or how receptive to new things they are. Only a few ones that contain particularly strong clues to affect or sentiment are highlighted in this chapter. This list of words affective lexicons or sentiment lexicons having the meaning of affective or connotation. Defining emotion. Most significant affective classes is emotion. Several language processing tasks may be enhanced by emotion recognition, like in medical NLP tasks for helping diagnose depression or suicidal intent. Understanding student mode, ancestor times, society's behavior. These are used in this also. Two groups of emotion theories have served as the foundation for the majority of computational model of emotion in NLP. Basic emotion. 6 emotions proposed by Ekman. 8 basic emotion in 4 opposing pair is the theory of Plutchik, known as the wheel of emotion. Most of the models included two dimension, valence, arousal, and many add a third, which is dominance. Available sentiments and affect lexicon. The most basic label words along one dimension of semantic variability, generally called sentiment or valence. The most basic lexicon, a word list for positive word and word list for negative words, are used to express this dimension in a binary way. There are different types of lexicon which are generally inquiry, the MPQA subjectivity lexicon, polarity lexicon, NRC lexicon assign valence, arousal and dominance LSWC. Linguistic inquiry and word count is desired to capture aspect of lexical meaning relevant for social psychological tasks. Now comes to the affect lexicons by human labeling. The initial and still widely used way of creating affect lexicon is to assign human labels to each word. Crowdsourcing is common now, breaking the assignments into manageable bits and spreading them to a large number of annotators. Emotions were classified by NRC emotion lexicon in two steps. Then the annotator labels it. The NRC VAD lexicon was created by choosing words and emoticons from previous dictionaries and crowdsourcing annotation using best or scaling. Annotators are requested to rank n things according to a property, ranking the best item as the highest and the worst item as the lowest. And now comes the semantic axis method. Here is two group of seed-based semi-supervised lexicon induction algorithm, axis-based and graph-based. A slight extension of algorithm based on computing is semantic axis. There are two ways to cope with the reality that a word's impact varies depending on the context. For each of the pole words, compute the impeding or computed directly on a specific corpus. In fine tuning, begin with off-the-shelf embedding, like word to wake, and continue training them on the small target corpus. This is all from my side. My fellow groupmate will be continue the rest. Thank you.
So hello everyone, I'm Anuna. The next we have label propagation. We will describe simple SendProp algorithm which has 4 steps. The first one is define a graph. So we will have some word embeddings, and we need to build a weighted lexical graph by connecting each word with its k nearest neighbors. Then the second one is defined a seed set. So we need to choose some positive and negative seed words and define a seed set. Then the third one is propagate polarities from seed set. So now we need to perform a random work on the graph and starting with the seed set. So we need to start with a node and then choose a node to move with its probability proportional to the age probability. Then the fourth one is create word scores. So we need to work from both positive and negative seed sets and resulting in positive and negative raw level scores. Then we need to combine these into positive polarity scores. And the fifth one is assign confidence to each score. Because sentiment scores are influenced by the seed set, so we'd like to know how much the score of a word would change if a different seed set is used. Then we also use other methods so other methods have been chosen for other kinds of distance metrics besides embedding cosine. So we need to choose two adjectives that are considered similar if they were frequently conjoined by and then rarely conjoined by but. So semi-supervised algorithms use a human-defined set of seed words for two poles of a dimension and use similarities metrics like embedding, cosine, coordination, morphology, etc., and see how similar they are to be positive seeds and how dissimilar to the negative seed. Then we have as our next supervised learning word sentiment. So it is a supervision signal. Then one such signal is course associated with the online reviews. Instead of just a binary polarity, this supervision allows to assign a word of to be more complexity. Then it is a representation of its polarity. So function like likelihood or normalized likelihood, many other functions of the count of a word occurring with a sentiment level have been used. So then the next we have is log-odds ratios informative dirichlet prior. So it measures the difference in frequencies, and it is a useful method for finding words that are statistically overrepresent in one particular category of text to compare another. Then we have the next using lexicons for sentiment recognition. So in supervised training data, if the supervised training data is available, the counts compute from sentiment lexicons, sometimes weighted or normalized in various ways, and can also be used as features in classifier along with the lexical or non-lexical features. So then we have um, using lexicons for after recognition. So we can also use lexicon features then used in supervised classifier. However, they are defined. These lexicon features are used as supervised classifier to predict the desired effective category for the text or document. Once a classifier is trained, we examine the which lexicon features are associated with which classes. For a classifier like logistic regression, the feature weight gives an indication of how associated the feature is with the class. So that was my part. The other part will be explained by my other group member. Thank you.
Hello, I am Sanjeev Kumar Sen and I will continue summarizing the rest of the passage from this chapter. So, using lexicons for affect recognition. So, detection of emotions can be done by generalizing the algorithms described in the previous part, which is using lexicons for sentiment recognition. Apart from that, the most common algorithms involve supervised classification, in where after the training sets is done being trained, the lexicon features are then used in a supervised classifier to predict the desired affected category for the text or the document. Now moving on to the next part, lexicon-based methods for entity-centric affect. So the entity-centric method of Field and Scope 2019 combines affect lexicons with contextual embeddings to assign an effect score to an entity in text. In that case, the algorithm first trains classifiers to map embedding to scores. For example, for each word W in the training corpus, it uses BART as well as some technologies like embeddings of each instance of W to obtain a single embedding vector for one training point. And it also uses the NRC VAD lexicon to get SA and PA scores for W. Then it trained three regression models on all words to predict VAD scores from a word's average embedding. Now, after that, use the same retained LM to get a contextual embedding for M in context. And after that, it feeds this embedding through the three regression models to get SAP scores for the entity. So this is how the SAP tuple for a given entity get mentions actually. Now moving on to the next section, connotation frames. So, so the lexicons my friend have described in the previous part are so far defined a word as a point in affective space, but a connotation frame is a lexicon that incorporates a richer kind of grammatical structure, which combines affective lexicons with the frame semantic lexicons. So basically, it acts such a way that a predicate like a verb expresses connotations about the verb's arguments. So, as we have reached at the ending of the chapter, now I'll tell a brief summary about the whole chapter. So, first, emotions. Emotion can be represented by fixed atomic units, often called basic emotions, or as points in space defined by dimensions like valence and arousal. And connotational aspects. Words have connotational aspects related to those affective states, and this connotational aspect of word meaning can be represented in lexicons. Semi and full supervised. Lexicons can be built with semi supervised as well as learned in a full supervised manner. Then, rule based classifier. Lexicons can be used to detect affect in a rule based classifier by picking the simply majority sentiment based on counts of words in each lexicon. And finally, connotational frames expresses richer relations of affective meaning that a predicted annotates about its arguments. So this is our whole presentation for the chapter 20 of Natural Language Processing course, which is Lexicons for Sentiment, Affect and Connotation.